Now that I've discussed the basics of addition, subtraction, and multiplication, I'm going to look at a couple of operations that are unique to matrices. The first of these is the transpose. The transpose of A is denoted by this A to the T. And with a transpose, we're just going to switch the rows and columns. What was a row in A is going to turn to a column of A transpose. What was a column is going to turn into a row. So let's look at an example of this. Here I have a 3 by 2 matrix A, and I want to find A transpose. We can see the first row of A is -6, -7. So that's going to turn into the first column of A transpose. The second row says -8, 9. So that's now my second column. And finally, my last row is 6, 4. Which is going to turn into my last column of A transpose. So all I did was just switch the rows and the columns. Let's look at a couple of the properties of transpose. My first property says that A transpose transpose is back to A, which should make sense. I essentially took a row, turned it into a column, and then took a column and turned it into a row, so I should be back to where I started. The second one says I can distribute a transpose over a sum. So A plus B transpose is the same as A transpose B plus B transpose. The next one says that A times B transpose is equal to B transpose A transpose. If I try to distribute it over a multiplication, I need to switch the order of the multiplication. And finally, if R is a scalar, then R times A transpose is equal to R times A transpose. So if I want to transpose a scalar multiple, it's the same thing as just finding the scalar multiple of the transpose. While I will not prove any of these, I highly encourage you to try to do them yourself. The next operation I want to look at is the trace. But in order to look at the trace, I need to start with the definition of a main diagonal. The main diagonal of a matrix are the elements A11, A22, A33, etc. The idea is we start at the top left corner and we just go down diagonally. The trace of a matrix A, denoted by this TR of A, is then the sum of the main diagonal entries. So let's look at an example of this. Here I have my matrix A, and I want to find the trace. So I start by figuring out the main diagonal. Like I said, start at the top left and go down diagonally. The trace then adds these elements up, so -6 plus 9 minus 1, which is equal to 2.